Going to start off with physics ATP paper, which is 5054/42 May June 2022 variant, and we are going to start off with this paper. So the first question is, let's move to the first question. The first question states that a student determines the thickness of the glass in a test tube. The student uses a ruler and the two rectangular wooden blocks to help him measure the external diameter of the test tube. Describe with the aid of a diagram how the student determines an accurate value for D. So okay, so first of all we need to see this thing. What apparatus do we have? So we have two wooden blocks, and we have a ruler, and we have a test tube. Okay, so first of all I'm going to draw the diagram of this test tube. Let's suppose we are putting our test tube like this, and we are going to make our wooden blocks like this. Let me change the colors of my wooden blocks, and this guy is going to be like this. So you can see this is a sort of aerial or the front view. So these are my blocks. This is how I'm going to place them, and then my scale would be coming on to this direction. There is go, and I will be taking this reading, and I will be taking this reading. So avoid the parallax error, and this is going to be, let's suppose this is length 1 and this is length 2. So for the external diameter I will do this L2 minus L1 to get my external diameter as accurate as possible. So this is how I'm going to do this. So you guys can write the theory as well. So I hope you understand this question how it's going to be. Okay, now coming to the next question, and it states that the students claps the test tube in a stand, fills a measuring cylinder to 100 centimeter cube marked with water, pour some water from the measuring cylinder into the test tube. So you have to put these things into your mind, because might be they have to do certain things in the next procedure or steps. The arrangement of the apparatus is shown in figure 1.1. The test tube containing water is also shown full size in figure 1.1. So this is the test tube which is fixed or clamped, and they have zoomed in the image, and this is going to be the height, and this is going to be the diameter of the test tube. So let's see what they are asking. Measure the height of the water in the full size test tube in figure 1.1. I'm sorry. Okay, so what you have to do is, now you have to measure the height. So whenever this question comes that you have to measure this thing, so it means that you need to use your ruler to measure the height. So if you put your scale over here or scale over here, so you will understand, or you will find out the reading of this. Make sure avoid the parallax error, the level should be same. Okay, and for finding out the readings, okay, let me put it on a bench first, or a level surface. First of all, this is going to be the precaution, and then it's going to be the, you can use a set square as well. So a set square would be helpful in taking the reading correctly. Okay, but at the moment you guys have to put a scale and find out the reading. Record the height in centimeter to the nearest millimeter in the second row in table 1.1. Okay, so if I measure this height, so it's going to be like 3.2 centimeter. Okay, and next is the record it in, we have done this part. Okay, figure 1.2 shows the VR of the water remaining in the measuring cylinder. So record VR in the table 1.1 as well. So there might be a table over there. So first of all we have to see these values, how much water is there. So it's going to be 89 centimeter cube of water is in there. Calculate the volume of water in the test tube. Now you see this thing which I was telling you, he pours some of the water measuring cylinder into the test tube. So this point refers to that question, how much water he has poured into the test tube. So let's how much water he has poured into the test tube. So again, refer to this thing that he has used. He has how much quantity of water? Yes, it was 100 centimeter cube. So he has poured this much water into the test tube. So the reading will be 11 centimeter cube, because 11 plus 89 is going to be 100 centimeter cube. Now let's see the table. Okay, the height is again that was 3.2 centimeter. Already units are mentioned. So the volume of the liquid in the measuring cylinder was 89 centimeter cube is written, no need to write it down. And volume of V is the volume in the test tube. It was like this. Okay. Now what says this? The students add water from the measuring cylinder into the test tube, measures and records the new value of H and VR in the table 1.1. Repeat the procedure for 3 more values of H and VR. The student results are shown as it is. On the grade provided, plot graph of V on y-axis and against H on x-axis. These are the important points, and you have to start with this, and then you have to draw the best fit line. Again, V is let me zoom out. V is going to be okay. They have already mentioned this thing over here. So if you see the graph, if you see the values, so how you are going to do this thing? Like for the volume, the figures are. Can I take it? I can take it like this. It's going to be. This is going to be 10. This is going to be 20, 30, 40, and what else is there? Okay, 40, and this is going to be 60. And okay, I'll draw till this point. Can I change the values? Okay, I'll change the values because the volume is 89 and we cannot get this thing over here. So let me change the values, and I'll redraw it and make it 20, 40, 20, 40, 60, 80, and then it's 100. This is on x-axis, and sorry, on y-axis, and the height will be on x-axis. Okay, so for this I will do 2, 4, 6, 8, 10, 12, and this is going to be 14. So now if you draw these graphs starting from 0 0, so the graph would be somewhere like this. Plot those values, and then you will get this graph over here. So you have to draw the best fit line. Okay, the next question is calculate the gradient of m of your line, show all the working and indicates there on the graph. So if you plot those values, and the graph would be like this. So my gradient values when I have done this paper, so it was like I've taken these 2 points, and these 2 points has a values of 4 and 15, and this point has values of 12 and 44. So if you take the gradient of this, so you must know the formula of gradient is y2 minus y1 over x2 minus x1, which is going to be 44 minus 15 upon 12 minus 4, which is like 3.625. So you can round it off to 3.6. If the test tube is perfect cylinder, then the internal diameter of D is given by the equation this. Use the value of this. Okay, so now D is equals to square root of 4, M is 3.6 divided by pi. You use the calculator and get your values, which is going to be 2.17. So it's easy. Your value for D is approximate. State one difficulty in measuring the height of water in the test tube and suggest how difficulty can be removed. So first of all, what difficulty we can have is the alignment. and the alignment of the test tube and the ruler, alignment of test tube and ruler. Then it can be the level of test tube, level of test tube. Then it can be holding up because the level of the liquid is not proper, and you can see this thing, you might be holding the test tube incorrectly, or it might be in slant condition. So holding it vertically or straight. And what will be the suggestion? You guys can write any of the one suggestion difficulty in this question, because this carries 1 mark for the difficulty and 1 mark for the suggestion. So for the suggestions, guys can do this. Put it on a horizontal surface. You can do this. Use the set square. Use of set square, which I have already mentioned to find out the value. So this the value will be sort of more accurate when you use this procedure. So just another reason why your calculated value for D is approximate. Okay, it's approximate because the bottom of test tube is round. It's not perfectly like square thing. Then as in case of volume, the accuracy is 1 centimeter cube, up to 1 centimeter cube, and the height you have taken is also approximate, because so any one of the reason can be the examiner gonna give you for 1 mark for that. So you guys can write any of the reason over here. Measure the external diameter D of the full size test tube in the figure 1.1. Okay, so in the figure, you must have remembered this thing, that this was the level of the liquid, so this was the height, and this was the diameter. So basically he is asking again measure. Okay, so you have to use your scale, and you have to measure the diameter, and it's going to be like 2.4 centimeter. Okay, use your answer in E2 and G1 to calculate the thickness of the glass in the test tube. So if I take those values, so it's going to be 2.4 minus 2.17 divided by 2, so you'll get 0.12. So this is going to be again quite easy and simple. Okay, a student investigates the cooling of a hot water in a beaker. The student measures the room temperature before starting an investigation. The room temperature is 24 degrees Celsius. The student pours 150 centimeter cube of hot water into the beaker, places a thermometer in hot water, wait for 30 seconds, reads the initial reading of the hot water, and starts the stopwatch. Records the temperature theta and on the hot water theta of the hot water every 60 seconds for 300 seconds. So what he did is, like, he poured the water into the beaker, and then he checked the temperature of that water after every 30 seconds. The student readings are shown there. Suggest why the student wait for 30 seconds before reading the initial temperature of the hot water. So obviously, basically he has done this thing. He has waited 30 seconds to allow the thermometer to respond properly or uniformly. And you guys can also write it down. It can be also stated that like this: adjust the temperature of the water, so that the thermometer can adjust itself to the temperature of water. Uh, Calculate the average rate of cooling R1 of the hot water during the first 60 seconds. So first 60 seconds is like this. These are the two temperature readings that we are going to take. 89.5 minus 83.0 divided by 60 because we are talking about average, and the formula is also given over here. So it's going to be 0 0.01. Oh, my bad. It's going to be 0.108 degrees Celsius per second. Calculate the average rate of cooling R2 of the hot water from T240 to this. So again, you see that temperatures are over here for 240. This is the temperature, and 300. This is the temperature. So you subtract 69 minus 66 over 60. So you will end up with 0.05 degrees Celsius per second. Moving to the next question, and it states that use the value you calculated in part B to describe how the rate of cooling of the hot water changes as hot water cools. So obviously the rate of cooling has dropped. Rate of cooling is dropped because how, you see the temperature which we have taken is was 0.108 to 0.05 degrees Celsius per second. So both have the same units. Okay, at the end of the investigation, the students leave the water in the beaker, predict the final temperature after 2 hours. So now you see, if you go back and you have seen that there was the room temperature was mentioned over there, so you can write it down, the room temperature or the 24 degrees Celsius. So that was easy again question. Suggest how the student ensures that the temperature reading are as accurate as possible. So how you are going to get accurate reading? So for you can use digital thermometer. One thing is, like, one way of doing this is finding out the taking the reading with the digital thermometer. You guys can stir the water, stir the water before taking reading, before noting down the readings. Again, I am writing 2 or 3 ways, so you guys can uh, opt for one, and make sure that the thermometer is not touching beaker, because we are more interested in the water rate of cooling of the water. Okay, moving into the next question, and it says that the three students A, B, and C measure the speed of sound in air. Student A and B stands at the opposite end of the football pitch. Student A strikes two large blocks of wood together. Student B starts stopwatch when she sees the block hits each other, and stops the stopwatch when he hears the sound. Okay, this is basically procedure how they are going to measure the speed of sound. So the time t recorded are this. Calculate the average. So 0.45 plus 0.41 plus 0.51 divided by 3, and you will get 0.456 seconds. So you will round off 0.46 seconds. The distance between D between the distance D between student A and B is 119 meters. Suggest a device that can use to measure this distance. Okay, again you can use a measuring tape, you can use a trundle wheel, or you can use laser to find out the distance. Calculate the value of V for the speed of sound in air. Use this equation. So what was the distance? It was 119, already mentioned over here, divided by the time, and time is 0.46 second. We have already calculated over here. So 0.46. So the speed of this is going to be 258.6 meter per second. Suggest one reason why the value calculated in B2 for the speed of sound in air is only approximate. So it's basically the reaction time error, because humans are involved whenever human are they have to start or stop a watch. So their reaction time may differ, because one student may be performing that experiment very quickly, but the other student is going to perform it slowly. So there is basically the reaction time error. and it is difficult because to start and stop in this time. Like for example, if you see this thing 0.4 second, so this 0.4 second is a very small time, so it's going to be quite difficult for a human to start and stop for this particular period of time. Okay, now moving to the next question, and it states that a student investigates how the resistance of a filament lamp changes when the current through it is varied. A student connects the circuit diagram in the circuit shown in this figure. The student has connected the circuit incorrectly. Okay, in the space below, redraw with the voltmeter and ammeter connected in the, so only you have to redraw with the correct voltmeter and ammeter. We know this ammeter is connected in series and voltmeter is connected in parallel. So there are two mistakes. One is this one and the other one is this one. So what we are going to do is like we'll redraw this, and there will be ammeter will be here. This is going to be the lamp, and lamp then is going to be variable resistor, and this is going to be connected with this, and your voltmeter will be coming across this lamp. Okay, when the switch is closed in the correct circuit, the student observed that the lamp does not appear to light up. The filament of the lamp is not broken and the battery is not run down. What observation does the student make to confirm quickly the filament of the lamp is not broken? So he will observe the reading on the ammeter. Ammeter will show response, or will ammeter will respond or will show readings. You guys can rephrase this word. Okay, suggest why the lamp does not appear to light up. It might be the resistance, which is too high, that the current is cannot pass through that. A current is too low, obviously, when the resistance is too high. So again, you see this one mark, so I will be possible scenarios that why the lamp does not appear to light up. Resistance is too high, current is too low, maybe there are broken wires, or you can see this thing, the lamp rating uh, is higher, the ratings higher than voltage supplied. So this might be another reason. And then again, not enough voltage, you can also write it, not enough voltage. So out of these reasons, you guys can write one of the reason over here. So this is going to help you in attaining your 1 mark. So if you have any question, do write me on the comment box. I'll be answering them. Thank you very much. Take care.